Hey ladies and gentlemen, today we're going to go through our minerals notes. So what are minerals? Minerals are simply just the building blocks of rocks. They are what make up different types of rocks. So here we can see this one rock is made up of several different types of minerals. Now, first example of a mineral is an uncut diamond here. It has several uses. It can be used to diamond tip different tools so that they're sharper and they don't wear down as much, or they're commonly used for jewelry. There's fluorite. Fluorite is commonly used in fluoride toothpaste. And selenite gypsum is very commonly used in drywalling, gypsum board. Now, there are 4 criteria for something to be considered a mineral. It must be naturally occurring, so not man-made at all. It must be inorganic, so it's not made of anything that was once alive. It's solid under normal conditions on Earth, so it's not going to be molten or anything like that in room temperature. And it must have a definite, oh, here, hold on. Must have a definite chemical structure, so it's going to have a crystalline structure of some kind there. Not let me move the camera out of the way. Sorry. So our mineral properties, these are going to be the physical characteristics that come from the atomic structure of this mineral. So we can see that different minerals have different atomic structures, just the way their atoms and molecules are going to line up with each other. So crystal shape is that first mineral property that we're gonna take a look at. Determines how it's going to form, different patterns in that crystal or in that mineral. Luster can affect how light is reflected off the surface. So basically, it's going to make some things are going to be shiny, some things are going to be not very shiny at all. So we have a metallic luster, submetallic, silky, earthy, dull. So there's different ways that things can appear. That's how we can also help identify different minerals. There's the streak color. So the streak is the color of that mineral in its powdered form. Sometimes it's going to be different than how it looks when it's all as one thing. So you can see that this right here looks pretty black, but it's leaving a red streak. So what we use is an unglazed tile as a streak plate for that, and it does a pretty good job of allowing us to rub the mineral off on the tile so we can observe its powdered form. Here, this one right here is a black mineral that's leaving a white streak behind. So the powdered form of the minerals can often be a different color than the mineral itself. There's hardness, which is the mineral's ability to resist scratching or denting. We use what's called the Mohs hardness scale to test this. Different types of items will be used to try to scratch the minerals, or the minerals will try to scratch those items. If those items can't scratch that mineral, then the mineral is harder than that item. So like a steel nail here falls at about a 6.5 on the hardness scale. If the steel nail can scratch something, it's going to be lower on the scale. And if the steel nail can't scratch it, it'll be higher. And we have all the way down here by 2 and 3, we've got a fingernail at 2.5. It's those are generally going to be your softer minerals right there. There's cleavage, which is the tendency of a mineral to break or cleave. Cleave means to split. So cleave or break along a plane of weak bonding. So this is going to be if we were going to drop a mineral or hit it with a hammer, it would determine how it would break into smaller pieces. It's going to try to keep some sort of repeating structure to it. We can see a number of different things where we've got different planes that sit on top of each other, kind of a puzzle piece shape here, where we have it in multiple directions. Or you might have seen some more interesting minerals that look like a bunch of little squares pieced together, where we have it in set where we have that cleavage in several directions right there. So those are all just different planes that crystalline structure is going to create, and it's going to allow it to break along those planes. You can see this right here, peels apart. All right, fracture is breaking without exhibiting cleavage. So if it doesn't have any repeating planes or anything like that that it wants to break on, and it doesn't break into any similar shapes or pieces, that's just going to be fracture right there. These, we can't see any kind of rigid structure or repeating shape. These would just shatter. There's density. The way we calculate density is we take the mass of that mineral and then we divide it by the volume of that mineral. And that will give you the density. But the density is how much matter is in a given space for any given mineral. Now, with most minerals, we have to find the volume by difference by using a graduated cylinder here. To do that, you find the volume of the graduated cylinder, record that, and then add the mineral to the graduated cylinder, and then find the difference in that volume. So you can see that the water level went up. That difference in water level is equal to the volume of the mineral you just added. Then there's specific gravity, which compares the weight of a mineral with the weight of an equal volume of water. Provides a more consistent basis of comparison for these minerals. All right, ladies and gentlemen, that concludes our mineral property notes here. I hope you guys all have a great day.